Welcome to another Stable Diffusion tutorial. Today we'll be looking at ways to integrate Stable Diffusion into Photoshop. For this tutorial, we'll be using comfyui and Stable Diffusion. If you don't know how to use comfyui or haven't seen the first video about how to install it and run your first generations, please do so before attempting to do this. In this tutorial, first we'll beat the node workflow, and then we'll see some of the use cases that such a workflow can actually have in a production environment. As always, you'll be finding the workflow files in the description, as well as any model you might need for these. And remember that if you're missing something from the workflow, you can just install missing nodes or missing models from the manager. And if you don't have the manager installed, you can go back and watch the first video where I explain how to do so. And that's about it for the introduction, so let's go build some nodes.
So, first of all, we're going to set up the node responsible for communicating with Photoshop. Double-click and search for Photoshop to comfyui. This node has a password field, which is going to be put into Photoshop later, and for now it's 12341234. It has an image output, which is the actual active image on Photoshop, and since we might be working with larger images, we want to resize it to a resolution we can work with on Stable Diffusion. So drag and drop and search for a resize node. We will input 1024 by 1024 for resolution, since it's big enough to have enough detail and it's small enough to still be fast for real-time generations. If you don't have some of these nodes, don't worry, you can install them via comfyui manager by going to manager, install missing nodes. The next thing we need is obviously a model. Search for load checkpoint and select your model of choice. In my case, it's going to be Epic Realism. Then search for the load VAE node to load up a VAE if necessary. Since we want to be able to generate in real time while we're working on Photoshop, we want to work with LCM, which offers faster generation times than regular models. Search for the load LoRa node and select your LCM model. By the way, you will be able to find the link to all these models in the description below. Next up is the K-sampler node. Search for it and set it up, then search for the VAE decode node and the preview image node, which, although not strictly necessary in this workflow, offers some debugging insights if needed. These are the main inputs and outputs nodes. But what goes on in the middle of the workflow? Well, let's start by connecting the load checkpoint model output to the load LoRa model input, and connect the load LoRa model output to the K-sampler model input. This will make sure that the model is loaded, passes through the LCM LoRa, and is then loaded into the K-sampler. Next, set up the K-sampler settings. Since we're using an LCM model, we want to have a lower than normal number of steps and CFG. So let's put 8 steps and 1.4 CFG. Set the denoise to a starting setting of 0.4 and the sampler name to LCM. Then we connect the clip output from the load checkpoint node to the clip input in the load LoRa node, and create our clip text encode nodes from the load LoRa node clip output. Connect the conditioning outputs from the clip text encode nodes to the positive and negative inputs in the K-sampler. This will be our positive prompt text box and our negative prompt text box. Then we connect the VAE output from the load VAE node to the VAE input in the VAE decode node. On the same node, connect the latent output from the K-sampler to the samples input. Then connect the image output to the image's input in the preview image node. We are now missing a latent image. Since we want to be working with pre-existing images sourced from Photoshop, we'll be working on an image-to-image workflow. Search for the VAE encode node, hook up the image output from the image resize node to the image input, and the same VAE we're using to decode to the VAE input on the VAE decode node. Then hook up the latent output to the latent image input on the K-sampler, and we're done. Or, well, almost done, since we need a way to display the resulting images somewhere else than the comfyui webpage. Search for the preview pop-up node and hook it up to the image output in the VAE decode node. This node will create a floating window that we can place beside our Photoshop workspace, displaying our generated images in real time. Now for the prompts. For the first experiment, we'll do stick figures, so we'll start with a generic prompt like photo of a young woman standing on a beach in front of the ocean, and some negative prompts words we don't want to see, like illustration, 3D, render, and not safe for work related stuff. Now that the node chain is completed, we want to head over to the right-hand side menu. Click on Extra Options and click on Auto Queue. This will keep the node chain going once started. We can also set it up so that it will only queue when it detects a change, or we can set up the Photoshop to comfyui node in the same way too. I'll keep false for both since I want it to be generating images continuously. Everything is ready, so let's head over to Photoshop. Click on Edit and navigate to Remote Connections. Click on it and locate the Enable Remote Connections field. We want to click it and input the same password we set in comfyui in the Photoshop to comfyui node, like 12341234. Once that's done, click OK and the connection should be established. In order to check that, we can just hit the Q prompt button inside comfyui and the generation should start by sourcing from the blank image on Photoshop. Once the generation is done, a pop-up will, pop up, and that's our preview pop-up node working. We can place it where we want it on our screen and then click on the pin button and it will stay there even if we click somewhere else or switch programs and windows. Now to actually draw something. We'll start by drawing a crude human figure. And as you can see, the pop-up is being refreshed as soon as the generation process is done, which is quite fast for now. Even if we keep adding details though, the generating image is quite the same as the one we're drawing, and that's because we have a denoise value that is quite low. So let's try to up it to something like 0.8. As you can see, now we are generating images that aren't crude drawings anymore. But since the generated pictures are quite random, we might want to tune in the settings for the K-sampler a bit more. So let's tinker with the denoise value until we find the correct parameter for what we want. In this case, the outline is there, but the picture is in black and white. We can then try to fill in the white spaces with color, like a blue for the sea, a brown for the sand, and a light blue for the sky. We can also tinker a bit more with the denoise value, like in this case, where we went down to 0.65, then 0.7. As you can see, the generated pictures are now much closer to the original, and if we add more details, the generated pictures will be more detailed too. The face will be in the correct place, the clothes will be similar to what we drew, etc. But this is just the beginning. Let's start with the picture of a model. In this case, we want to dress it up. But first, as you can see, the generated picture is struggling with the concept of depth. In order to fix that, we can set up a control net. Search for Apply Control Net Advanced, then hook up the conditioning nodes so that they will go through the Apply Control Net node. Since the generations are going on right now, we'll finish linking them later. Then we need to search for the Load Control Net Model node, where we'll look for the depth model. You'll find it in the description below, or you can search for it in your comfyui manager Install Models tab. Hook up the Control Net output to the Control Net input, and now we are only missing an image. First, we need a way to extract a depth map from an image. We'll search for the Midas depth map node. But we don't want it to process a 1024 image, so we'll duplicate the image resize node and set it to 512 by 512, and hook up the resized image to the depth map node, and the resulting depth map to the Apply Control Net node. We will then close the circuit by hooking up the positive and negative outputs and inputs. And we got an error, because I forgot to hook up the new image resize node with the Photoshop to comfyui node, so there's no source to resize. Let's fix that and hit Q prompt again. As you can see, the generation is a bit slower now, but the depth of the generated picture is much better. Going back to Photoshop, I will pull up some clothes. The pop-up will refresh with an image of a model with a sweater on top, and will try its best to make sense of it. The light is kind of coherent, and it warped it to follow one of the arms too. But since we would like a better approximation, we can try masking the sweater and warping it so that it fits the body a bit more nicely. Keep in mind that while we're warping, the preview will not update, since the underlying image is still unchanged. But as soon as we confirm the warp, the resulting image will be a lot better than what we have in Photoshop. We can do the same for a skirt now, and as you can see, it's already quite good, even adding some sort of pockets on the side. If we mask and warp the skirt, it's going to result in an even better generation. If we don't want a pocket, we can just mask in the corresponding hidden hand. So the generated image is adding coherence to the rough post-processing we've done, all in real time. Quite good to use in pre-visualization stages of productions, if you ask me. The clothes, though, are a bit different from the reference still. This is because we're using LCM. We can try and switch it off and use a normal sampler, sacrificing some speed in the process, and see if that works too. In order to do that, right-click on the Load LoRa node and select Bypass. This will result in the chain still working, it's just not going to be affected by the bypassed node at all. Then we can select a more usual sampler like DPM-PP2M and a more realistic scheduler like Keras. If we resume the generations now, though, we can see that the resulting image is quite bad. That's because while LCM can work well with a low number of steps, normal samplers just can't. So let's go up to 14 steps and set the CFG to 2 and generate again. A little better, but the denoise value is still too low to notice any huge difference. Let's up the steps to 18, CFG to 4 and denoise to 0.4 and try again. The results now are much better, although the speed is not quite the same as before. It's a trade-off we need to be wary of. At this point, we can keep tinkering with the values until we find the parameters that work the best for us, depending on the situation at hand. But if we're doing pre-visualization, why stop at clothing? We can also insert a background, like a forest, or an interior. The generated image will be a lot more coherent than the mashup we set up in Photoshop, and with minimal effort. These are just some examples of what we can do in terms of pre-visualization, but it's a technique that can help in production environment. The only thing that's not really working though is the shadow, and that can be taken care of with some post work. Let's check out one more possible application. We're going to generate some fashion illustrations, starting from this picture. Let's set everything back to the LCM settings, and we will change the prompt to reflect what we now want. So we'll write fashion illustration of a young woman as a positive prompt, and we'll remove illustration from the negative prompt, while adding paper so it doesn't look like it's drawn on paper. We will then up the denoising value to 0.8, since we want a very different style from the original image, and since we don't care for depth anymore, but we want the edges to be consistent, we'll switch the control net model from depth to canny. Now, the depth map node is not needed anymore, so we'll delete it, and in its place, we'll search for the canny edge node, which will pre-process the Photoshop image's outline. Hook it up, and we'll add watercolor as a style to the positive prompt, since we'd like to get some watercolor images. Now let's hit Q prompt. And going back to Photoshop, we can see how we can get some fashion illustrations effortlessly. The colors and the overall style is different, since we have a very high denoise value, but this lets us influence the overall design by painting over the original image if we want to, and get some different results very quickly. So, on the one hand, it's not precise, but on the other, it lets us brainstorm new ideas faster. It really depends on what stage of pre-production you are at. If we want to have more precise results, we can always tinker with the denoise and the other parameters, but this will be resulting in more or less realistic images. It's up to you to find the combination of parameters that work for you and to apply the correct workflow to you or your client's needs. And that's it for today. As always, you know the drill, please like and subscribe, as it helps a lot, since this is a new channel. I'm Andrea Baioni, and you can find me on Instagram at risunobushi or at andreabaioni.com. Also, please comment if you have any questions or suggestions for this or the next videos. See you next time with more workflows that can be applied in production environments for creatives.